I thought I'd show you really quick how to rearrange the formula from question number 9. So here's what I promised you. Here is the formula that we originally had. And in number 9, what are we looking for? We're looking for the velocity of the mini bike, so the velocity of the source. As we said earlier, if the mini bike is moving towards you, we choose this to be a negative sign and not the positive sign. If you're unfamiliar with that, once again, look on page 508 or 510, and they have the instructions when to choose positive or negative. And every time you do the formula, you have to look at those instructions. So I simply took this, which is bound by parentheses, put it up here, and took this frequency observer and put it below. So here it is rewritten. Now I land up with 1 minus V source over V sound is equal to frequency source over frequency observer. Next thing I want to do is I want to get rid of this 1. So what I do is I subtract 1 from each side. So we have negative 1 over here, and I subtracted the 1 over here and merely canceled out. So I multiplied both sides over here also by negative 1, because I hate negative signs on the side that I'm trying to solve for. So in order to get rid of this negative sign, I multiplied this by negative 1, and I multiplied this side over here by negative 1. So we land up with a positive on this side, a positive on this side, so everything looks good. But don't forget, this is still looking negative over here. So what I did was I just took this guy, put it over here, down here, so it looks a little bit cleaner. Then I took velocity of sound, and I multiplied both sides. So I put velocity of sound up here. It cancels with this one, so it goes away. And then I put brackets here and here, and multiplied by V sound on this side. So here's the way the formula is rewritten. Again, you're supposed to know how to do this. I hope you're able to follow it. If not, ask me in class. Question number 10. What frequency does the person on the back of the mini bike hear Adele singing? It's the same as the person driving the mini bike, because the person is the source. So they're moving along with the source. So there is no frequency change. And that's the funny thing. If you're in a car, you will never hear the frequency change inside the car if you have the music playing. But someone hearing a car go by will hear the change in pitch. Number 12. I'm sorry, here we go, number 11. At what frequency do the kids standing behind the mini bike hear Adele singing? Now, here's a little picture to help us have an idea. The mini bike with 2 people are heading towards you, and here are the kids. The kids are standing behind the mini bike, so they're going to hear a lower pitch sound. Well, what do we use? We use the formula we've been using all along. We use a formula for a moving source. Again, it's not a moving observer, it's a moving source. So frequency observer is equal to the frequency of the source, which is the mini bike, divided by 1 plus or minus V source over V sound. Now the interesting thing here is, here's where you have to make sure the positive and negative are correct. This object is moving away from the observer, so we have to take this to be positive. I just throw this in, it's a really easy formula to do, and we land up, they hear a 248 hertz sound. Again, Adele's singing at 262, but the frequency drops to 248. Let's look at problem 12. Problem 12 says, if the bike has a marker light that glows orange, at what frequency will you, the standing observer, see? Again, what do we know here? We know that the velocity of the bike is 20 meters per second coming at you. I gave you the frequency of the light, which is 485 times 10 to the 12 hertz. And we also know the velocity of light is 3.0 times 10 to the 8th meters per second. And the reason why we're using the velocity of light in this equation is because we talked about what is the frequency change of the light, not sound of the light. So we look at which Doppler equation to use. This is the equation for an object that is the source of the sound that is moving. So again, it's the mini bike that is moving and shining its light. So it is the source that is moving. Be very careful. This is the source that is moving. That's what this formula is for. and we just plug and chug. We got 485 times 10 to the 12th hertz divided by 1. And why do we use the minus sign in this case? Because the object is moving towards you. Again, the mini bike with the light is moving towards you. So in this case, it's negative. And where do you find this? You find this on page 508. The instructions for making this positive or negative is on 508. The only difference is instead of using sound, we are using light. We're using the velocity of light, which is the same thing as c. And our answer is 4.85 0.0000323 times 10 to the 16th. Now, if you look at what the original frequency was 4.85 0.0000000 times 10 to the 16th hertz. Now, why is it 10 to the 16th and not 10 to the 12th like it up here? This is up here. So I moved the decimal point over twice here. So, but if you look, we are talking about a very small change. Our eyes will see orange at 485, and it's still 485. 323. It's like saying I've got $4.85, and this is a small fraction of the entire number, so it really doesn't make any difference. Problem 13. At what frequency does the crowd hear the high note of someone singing the national anthem at the World Series? The crowd will hear the high note the same as the singer because the crowd is not moving relative to the person who's singing. How about an airplane? So you are in charge of flying your P-51 Mustang across the stadium during the World Series during the national anthem. I forgot to put the speed, which we talked about in class. So in class, we established that the speed of the airplane is 550 miles per hour, which is 250 meters per second. And we also established that the high, I think Destiny says was the high E is 620 hertz. So looking at the problem here, number 14, at what frequency do you hear the high note? Well, the velocity of the observer is equal to 550 miles per hour, which is 250 meters per second. The frequency of the source is 620. We just put it into the formula that we already know. We choose positive here because the airplane is moving. The airplane is moving towards the source in this case, and we land up with 1072 hertz. And our last question is, at what frequency will you see the red light on the Sox wind sign? Again, you are moving towards the source in this case, so this is the formula you're going to use. 425 times 10 to the 12th, that is the color of red light. You put it in this formula, and this time you do not use the velocity of sound. You use the velocity of light, which is c, which is 3 times 10 to the 8th meters per second. And again, if you write it out in non-scientific notation, look how small percentage of the number it is. It's very, very, very small compared to what you see. Again, red light will appear to you as 425, and look, the red light is still really 425. So you're looking at really, really small change here that your eye cannot pick up. So these are how you solve the problems.